Hey to all evaluators, I'm Lee Xiong. In this video, I'm going to present my FYP, which the title is Spotlight based on sleep activity. Recently, there are many functions of Spotlight available in the market. However, they are not available with Sleep Tracker. Therefore, this project is done to make a smart line based on sleeping behavior of a person. In this project, there are three problem statements. First is how to detect whether a person is asleep or not. Next, what is the maximum area or length that the smart line can sense? And the last is how long it takes for smart line to turn on or off. Next is about the objective of this project. First, to identify a person asleep or awake within the range of area for the sensor use. Second, to determine the time for delay to turn on or off the light. Third, to produce the prototype of smart light with sensor that can detect a person is sleeping or not within a certain area with a little bit delay to turn on or off. This slide shows the Gantt chart for FYP2. First is correcting the data as some mistake did when taking data during FYP1. Then analyzing those data and making prototype. This flowchart represents my methodology of the project. First is doing literature review about lighting system, sleeping behavior and sleep monitoring system. Next, doing hardware wiring and software programming. After that, data is collected in 10 times and be analyzed. Then a prototype is made based on the data collected. The figures in the slide is the setup when taking data. Movement is the data taken by using accelerometer, whereas motion is the data taken by using mini-human PIR motion sensor. Movement and motion of a person will be as the indicators to turn on or off the light. The slide shows the graph of movement in duration of half an hour for first reading. As shown in the graph, movement while awake will move more frequently than while asleep. However, a little bit changes of movement while asleep may due to changing of sleep positions. After that, modulus values of difference between current movement and previous movement are calculated. Then mean, mode, minimum, maximum, standard deviation and variance for raw data and difference value of movement for first reading are determined and listed as the table shown. All these data of movement are taken 10 times and be analyzed. Table in the slide tabulates this analyzed data of movement for 10 readings with its mean and max value. Highlighted value will be used as indicators of light. Therefore, for movement, if a person falls asleep, movement of the person should less than maximum value of difference while asleep, which is 19.3. If a person awake, movement of the person should more than minimum value of difference while awake, which is 0. The slide shows the graph of motion in duration of half an hour for first readings. The mini-human PIR sensor gives digital output where logic 1 indicates got motions, whereas logic 0 indicates no motions. From the graph plotted, the motion while awake are keep changing between got motion and no motion. For while asleep, there are only a few motion at short interval, mostly unknown motion. Table in the slide listed the distribution of output for 10 times reading with average. For motion while awake, number of logic 0 less than number of logic 1 indicates that more motion when awake. For motion while asleep, number of logic 0 more than number of logic 1 indicates that more non-motion when asleep. Since the output gives in digital form, thus the data are analyzed by counting each continuous occurrence. Number of continuous occurrence is how many times logic 0 or 1 occurs continuously. Figure on the left is an example when analyzing data of motion. This table shows the analysis of motion data. For motion while awake, that is the average of 9.51 times of continuous occur log 0. For motion while asleep, that is the average of 6.85 times of continuous occur log 1. Therefore, for motion, to indicate a person falls asleep, number of continuous occur log 0 should more than around 10 times. This implies that theoretically, the light will turn off after 5 seconds the person falls asleep. To indicate a person awake, number of continuous occur log 1 should more than around 7 times. This implies that theoretically the light will turn on after 3.5 seconds the person awake. After analyzing the data collected, this analyzed data will be the indicators to turn on or off the light. Figure on the left shows the proposed flow chart that will be used for programming of the prototype. Condition 1 is used to determine whether a person falls asleep or not, whereas condition 2 is used to determine whether a person awakes or not. Both conditions must be fulfilled with two requirements as shown in the slide. After completing this project, a prototype of smart light that based on sleep behavior of a person is made with using accelerometer and mini human PIR sensor. Both sensors used will limit the range of sensing. Theoretically, the light will turn off after 5 seconds the person falls asleep, and the light will turn on after 3.5 seconds the person awake. Therefore, the smart light able to turn on or off based on sleep behavior that can save energy usage.